All right, example two in 2.2 in Math 20-1. This is where our special triangles kind of come home to, not roost, that's a weird way of saying it, but we need to know our special triangle. And before we kind of examine what special triangle we need, I think it's beneficial to draw this out. So what I'm going to do is I'm going to draw on my wonderful Cartesian plane the angle 135. So 135 is going to go past my 90-degree kind of vertical positive y-axis there. And then it's actually going to be along this dotted line, which is halfway in between. So I'm going to draw 135 right there. And what I would recommend to students is as soon as you have the rotational angle, you should at least think about the reference angle. And in this case, I'm going to write it out. Theta reference is equal to 180 degrees minus theta, because we're in quadrant 2. I'll put that above there. Sorry, I should have wrote that first. And when we put in our rotational angle, I get that theta reference. I wrote 45 thinking of the answer, but I'm going to take 180, subtract my angle in standard position, 135, and I get that the reference angle is 45 degrees. So I'm going to put that little 45-degree angle right in there. And then what I'm going to do is I'm going to draw this triangle in so I can actually pull it out of this. Now, the reason that I want to talk about this is as soon as we see that our reference angle contains a 45-degree angle, that should be at least a bit of a, shout out, however you want to say that the 45-degree special triangle is what we're going to need in this case. Now, I know that we did those in 2.1, and a lot of students think, oh, I don't need to know this, it's not a big deal. You need to know them. And the reason that you do is in this case, if we look at our 45-degree special triangle that has an opposite and an adjacent of 1, and a hypotenuse of root 2, then what I can do is I can picture that special triangle in place on my angle. And what that does for me, I think I just locked those into place accidentally, is if I take that special triangle, and what I'm going to do is I'm going to superimpose it onto this, what it does for us is it actually shows us the x, y, and the r. The only problem is that we can't blindly trust our special formulas. We have to recognize that because this is in quadrant 2, we have a negative x and a positive y. Now, you don't have to write the positive on the y, but I think in terms of a nice technique that's going to work well, that is what we should be doing, just to make sure that we catch it. And what I'm going to do is I'm going to put in the information that gave us. Knowing my special triangle fits nicely into place with that 45-degree reference angle allows me to say that when the angle is 135, I could say that x is negative 1, y is positive 1, and r is the square root of 2. And the reason why that's so beneficial is that the cos of any angle is equal to x over r. Now we're going to get real specific for this question because we know the angle we're talking about and we know x and r. So I'm going to say the cos of 135 degrees is equal to my x, which is negative 1, over my r, which is root 2. Now, way back in chapter 5, we spent an entire chapter telling you that you can't have a radical in the denominator, and that's still true. So we need to use our chapter 5 skills to rationalize this denominator. Because the denominator is just a single radical, I'm going to multiply it by itself, but I have to multiply the numerator by the same value. I always like pointing this out several times a year that we can do this because that fraction is equivalent to 1. Multiplying by 1 doesn't change the value, it changes the appearance. And so what I'm left with, and I'll write all the steps here, is I get the cos of 135 degrees, negative 1 times root 2 is negative root 2. Root 2 times root 2, I'm going to write it here, is the square root of 4, but the square root of 4 is 2. So I can say that the cos of 135 degrees is equal to negative root 2 over 2. Now, writing out a statement like that, where we have, effectively a value on each side, is a really, really big benefit because we can actually check this on our calculator. And the way that we would check that on our calculator is, by grabbing it. And then, really importantly, we have to make sure that we're in degree mode. So in Math 20-1, you will never have to be in a mode other than degree. Make sure your calculator isn't kept in radians. When you reset your calculator, it goes back to radians. So I'm going to make sure that I'm on degree mode. And then what I'm going to do is I'm going to type in the cos of 135 degrees. Okay, good sign that it's negative, and then it gives me this ugly decimal. Well, if I've done this correctly, the square root, the negative square root of 2, almost messed up there. So the negative square root of 2, close the bracket, divided by 2, and we see that we get the same value. Now, I really want to push that the reason we can't just write this decimal is because that decimal goes on forever. The square root of 2 is an irrational number, so there's no pattern, there's no repeating decimal there. So we really write it as negative root 2 over 2 because that's exact. That negative 0.707 is an approximation that's useful. If you're building a shed, you probably only need that to the nearest hundredth. But if you're building a particle accelerator, you might need it to, the nanometers or something like that.